Hello everyone and welcome to this session of Midas NFX 2014 release webinar. So before beginning, I'd like to verify that you can hear me, so if you can just write a comment in the chat section, and we'll begin right away. Okay, perfect. So I'm Cyprian, the European International Manager for Midas NFX, and I'm with Piotr Stekin, the Technical Support Director.
Hello everyone.
And Apur Sharma, who will answer your question live. So let's begin the session right now. So what we'll talk today are about these four subjects. So first, we'll talk about the world's fastest theh, which is the, I will explain what it means. Then we'll talk about the new features of NFX 2014, which is the main goal of today's presentation, and what's coming next, so a few further improvements, and finally we'll talk about the next bits that we'll do. So first of all, we would like to present to you what we think that Midas will help you to solve for your problem, because we call world's fastest theh because you have fast modeling, fast work environment, fast contacts, fast solvers and results, and fast report generation, and finally fast learning. So I'll explain each of these points. So first of all, fast modeling, because you can import more than 12 CAD models. So the full support of all generally supported file types is included inside. And so then you have simple and intuitive work environments. So you have a work environment which is composed of simple ribbon menu, which is similar to MS Office template, so you will easily find all the functions and it's very easy to use. You have the work tree on the left, where you will find all the data of your model, the geometry, the mesh sets, the parameters, the material, and everything. So it's very convenient to find all that. And you have, of course, the main window where you work and you work. But the interface is quite simple and intuitive. Then you have also some automatic and manual simplification tools. So when you are working on huge and complex models, you can just use the tools which are in NFX to simplify automatically the small holes, for example, or you can simplify the small fillets as well. All that, so just selecting and removing them. But of course, you have also the manual options which are available if you need more specific simplification. Now, it's also a fast work environment because you can really tackle huge models made by more than thousands of parts. So this is also what we are proud about. It's you can really work on real engineering models. Now, what you can do in this new 2014 is not only to work on several models in one work window, but as well launch the solver on different models, and you can do several analyses at the same time. So it's very powerful when you have to work on several versions or several designs maybe of your model. So this is why it will make you gain a lot of time. Now you have also two main interfaces in function of if you are a designer or if you are an analyst. So the designer interface is made really for designers, so it's more easy to understand, and you will go right away to the results you need. Then the analyst mode is more complete with all the functions which are more advanced and all the modeling features as well. Now, what is really strong also about NFX is the fully integrated work environment, because you can perform all these analysis in one unique environment. So you can perform linear static, nonlinear, CFD, explicit, and it really makes you gain a lot of time because you don't have to do again the modeling, you don't have to switch the software or to export the mesh and try in another software. So this is all very fast work environment. You have the fast contacts because you can automatically assign any kind of contacts on assembly models, and you have also a contact manager to manage all that and to be sure that you assign the right contacts. You have also very fast meshing, and NFX includes, for example, the tetra mesh, of course, but you have also some specific kind of mesh called hybrid meshing, which is made of hexa and tetra, and this will improve a lot the analysis time, mostly because the number of nodes are divided by 3, and you gain accuracy at the same time because you are using hexa elements. So you have a small picture here to see what is this element. Now you have also fast solver.
Go to webinar. Webinars made easy.
Hello? Hello, is it working again? I think we had just a small... okay, you're back. I think our device had a small hitch. I'm sorry. Okay, let's go on. So I was talking about the different kind of solvers we have. So we have direct, multifrontal, iterative, and multi-core solvers. So all that is working with multi-core, and if you're working on 64 bits, it's really fast. But we have a new improvement that we'll talk right after, which is called the GPU calculation, and this is a new feature of NFX 2014, and we'll explain that a bit later. So you have also the ability to get fast results because NFX can also, when you're performing nonlinear analysis, you can get the result during the analysis. So it's very convenient if you want to see if your analysis is going well, for example. So you can open the result file and see the results, and you don't lose any time waiting for the end of the analysis. You have fast reports. Because you have now two types of report. The first one, which was already in the previous version, is the word report generation, which is customized and have all the data of your analysis in the report format. The second type is the 3D PDF report generation, which is a whole new feature of NFX 2014. And I will present that a bit later, but it's really a great improvement, and I really like it. And the last point, which is the fast learning, because we have a lot of materials, tutorials, video, everything you can find to learn how to work on the software. So actually more than 43 step-by-step tutorials, more than 10 simple guides about FEA analysis, more than 100 videos which are available on YouTube. And finally, you have also a free iPhone and iPad app if you have an iPad that you can download, and you'll get all the PDF on your iPad. Okay, now we'll go to the main point, which is the new release, NFX 2014, and we'll present all the new features that you'll get in this release. So let's begin with the CAD interface. So here you have a big table which is actually describing all the CAD formats that you can actually import with Midas NFX. So added the solid edge extension, and we also added some new versions of Inventor, for example, 2014, Creo 2.0, and in the next version of NFX R2. So you'll have SolidWorks 2014, NX9, and Solid Edge ST6. Now, on the mesh interface, we added the import of STL file. So if you're working on a 3D scanner, for example, it's particularly useful to be able to import the STL file directly in the software. We added the new batch analysis to perform several analyses at the same time. So you can put all your analysis and run it overnight and come back the morning and get the results. We have a new, so I'm talking first about the pre-post features, which I will talk about the solver features after. So this is the viewpoints. So you can now save your viewpoints and also import it from another model. So you can save it in a BPS file and just use this file. So we do that because usually when you find the right angle, it's difficult to find it again. So if you want to make good looking screen captures, you can, like that, save this file. Now, we had what is called the geometry auto connection. So it's also a pre-modeling feature which will help you a lot to do the modeling. So I'll show you quickly how to use this feature because it's really interesting and I like it very much. It simplifies a lot the modeling. So here you have the model that I will use. So it's a quite complex model. I don't know how many parts you have, more than 300 parts. And I'll just activate one small part here. So what you generally do is, and which is the most simple way, would be to just mesh it and to assign a contact, and then you can go on with the analysis. But in some time, it's better just to link the mesh set together than assigning the contact. So you may want to mesh it and to merge the nodes together. So if you want to do that, actually, it will be a bit difficult because you see I'm hiding the mesh and you don't have the imprint of this geometry on the other part. So I'm hiding that. I'm hiding the joint as well. You see that you have no imprint this model. So this is if you want to merge the nodes, it will be difficult, or you'll have to make manually the imprint on all the parts. So this auto connection feature is actually connecting all your parts together. Like so it's here, auto connection. You just select all the parts. You have a preview, so the preview will show you where it will connect. So here it will connect almost everywhere because there's no connection for the moment. I click on OK, and you see that in a few clicks it's done. So now I can hide, for example, this, and you see that the imprint has been done. So I can hide that, and the imprint has been done. So all that on all the parts. So now I can just mesh and check the function, merge the node, and all that will be connected, and I can launch the analysis. So it's the second thing that you can use this auto feature is to replace the Boolean operation, because I can show you a quick example which is very simple. Just say I create a new geometry, a cube, something like that. I create, let's say, a sphere. Will maybe decrease the radius. Okay, right here. And I want to connect these two parts, so I just choose auto connect. I choose the two parts, click OK. And now you see that if I highlight this, for example, I have the imprint on here. And if I hide the sphere, you see that the sphere has been moved from the box. So this is, the two parts are now connected, and you can measure that. This is the auto connection feature. Okay, now come back to the presentation. We have also a new small feature, let's say, which will help you to remove the imprinted edge of points on your model. It's sometimes useful when you have raw mesh on one side and you remove some edge. We improve the screenshots by providing new options to select an area, to screenshot all and new formats screenshot. And we have the auto range function. So this is working on the legend of the model. So actually, usually when you do analysis, you get the results, and the legend is not, let's say, homogeneous every time. So it happens that you have a big concentration of displacement, maybe, or constraint or stress in one color, and then very huge, let's say, stress in another color in the red. So you see only one small red point on the screen. If you use this auto range, it will automatically change that, so you have the same percentage of stress in each of the colors. So it's much more easy to visualize all that. Okay, now let's talk about the last boss feature, which is one of the best. We really like it, which is the 3D PDF. So I'll show you how it works in the software. So I'm taking a model. So this is a seal model that I showed you in the previous webinar. So you have the hyperelastic material. Let's check the stresses. Okay. So I want to export this model into PDF, maybe to share with my colleague, or just to show to someone who doesn't have the software. So you go in the tool menu, you click on 3D PDF, you just check the type of result you want to get. So you can export the geometry, let's say, and solid cornices, and let's say total translation. Well, I'll give a new name to this, and just click on OK, and it will generate this 3D PDF. So see it here. So hide tools here. So basically, this is a PDF format, so you can share it with your colleague, and you have your model in 3D inside. So you have several views. The first view is the model, so with the mesh sets. The second view is the results. So let's come back to this first view. So if you look at this walkthrough, you see you have the mesh sets that you can hide or activate. You can activate the boundary condition or inactivate them. You can inactivate the properties, for example. So if you do that, you see the command with that. And you have various options for the viewing of this. So I'll show you that with the results. So let's check, for example, the stress. So it's a displacement. Okay, let's check the stress. Let's go to stress. Okay. So have that. You have different kind of visualization. So if you want to say to view the mesh sets on the model, you can get view mesh. You can use different types of light if you want to have CAD optimized type of light. You have different options like the cross section, so you can cut your model along the cross section. Like that. If you want to see inside the model. You have also some tools to view the measurements of the model. So, for example, you can define first the unit of the model. Here it's a millimeter. And then you can take 2 points on your model and just give the annotation. So it's 3D like that. You can do as many as you want. So it's really easy to use. You can add some comments also, so if you want to say to tell your colleague that in this point, for example, you have a very big stress and you need to correct that. Okay, you can put this, but then you save the PDF and all that will be saved directly inside the PDF, so you can send it to your colleague. And I think that even if you have, so you can use that with a free account of Adobe Reader. You don't need to use any paying accounts, but you need to have the latest version, which is Adobe 11. So if you use that, it will be okay. And you have a few more options if you have a paying version of Adobe, like for example, you can send this PDF directly by email using the Adobe Cloud or something like that. But anyway, this is a good feature. Okay, I see we have some questions, but we'll answer that at the end because we'll still have a lot of things to talk about. Okay, so now let's talk about the second huge improvement in this NFX 2015, which is the GPU computer. So the GPU is the Graphical Processor Unit, so it's the one included in your graphic card, and you can now use that to compute huge models and go faster with your analysis. But you have to be aware first what it is and how to use it, and on which kind of device you can perform such analysis. So if you see the small picture here, the GPU is actually composed of thousands of cores, so whereas the CPU is only composed of multiple cores. But the way of working of these two units is different. CPU work in
Welcome to GoToWebinar. Webinars made easy.
For 1 or 2 seconds, is it okay? Did the audio come back? Hello? Okay, good. I'll continue. Okay, so I was talking about the CPU and the GPU. So the GPU is composed of thousands of cores, so that works in parallel, but you need a special type of coding, which is called the CUDA technology, which is used to perform the model on the GPU. So as in this small description, your main code is still working on the CPU, but some portion of code, the one which take the most of the computation power, are just switched to the GPU, who will compute that and go back the data for you. Now let's talk about the compatibility. You have to know that you need some specific type of GPU in order to be able to use this option, because there are some specific GPU which are made for scientific calculation, and you have the, let's say, the basic GPU one, the one we have in all computers, which is really made only for graphics or to play games. So you may have some very, very powerful card which is made for games, but and it may work with the GPU, like I'm thinking about the Titan, for example, the NVIDIA Titan or such models. But the thing is that in the model like the Tesla, which we recommend and that we are using here in Midas, you have optimized algorithms which are just verifying the accuracy of the calculation, because this is very important. If you have a very small mistake in the GPU, then it can lead to bad results, and then you have to be aware of that. So our hardware we recommend is this NVIDIA Tesla. Okay, go back on the next slide. Now let's talk about the second solver feature that have been added, is the mesh deletion for explicit analysis. So Piotr Stepian will explain about that and show you some examples.
Okay, thank you, Stepian. My name is Piotr Stepian, and I'm within Midas IT as the technical support engineer. So let me switch to the software at this moment. And right now we will start from the element deletion example. So I already prepared some model. So you're supposed to see this. And as you see, this is a simple model which provides you simple specimen. And this is the interesting improvement feature which is available in explicit analysis only. And this feature provides deletion of some part of your model when deletion condition will be achieved. So right now I will go to the model tree and I will click on the edit, because this deletion criteria is related to the material in Midas NFX. So in our case, as you see, I just implemented the nonlinear material, and at this moment, to activate this criterion, we're supposed to check this shear failure checkbox. So what we can do, we have to provide a value for effective plastic strain at failure. So in my model, let's assume it will be equal to 0.05, but you're supposed to, let's say, make some preliminary analysis to investigate how big are your strains. So I made that before, so at this moment I entered this value, so it's known by me already. Okay, so the material is still non-linear with some plastic hardening option. So I'm clicking OK at this moment, and this is the first requirement which is necessary to activate this material deletion. The second one, we have to go to the analysis case and go to subcase setting. So under the subcase setting, I'm clicking on subcase control, and from the general analysis control dialog box, you see we have two element deletion criteria in refer to the solver calculation. So now I'm checking the criteria which is specified in material, and additionally we can check the second option, which refers to, let's say, please delete elements with the negative volume. So second option I think will be more useful in more complex models, more complex than mine, because right now I have only one part and which is subjected to tensile loading, and it's relatively simple. Okay, so I will skip that, but you can use this to consider negative volume and your mesh will be deleted. So at this moment, element deletion criteria and specified in materials. Now I'm clicking OK, and I'm clicking OK. So all analysis setup like time step and time interval has been already provided. And I will not calculate this model right now because we have no time to do that. So I will open the result file. Okay, so the results has been loaded. Now I'm clicking on the result. I'm checking that the real scale has been chosen. Let's click on the total translation contour, and let's play the animation. So now I'm clicking on multi-step animation recording, and I'm selecting all subcases, and please provide me every second result. So I'm clicking OK, and let's.
Welcome to GoToWebinar. Webinars made easy.
Have a problem, so please give me information that everything is fine. So I will check this from my panel. So you're supposed to see the screen. Okay. So as you see, now I will display the solid strain effective plastic, and I will go to the Probe tool, and I will show you that strain for my model is equivalent to 0.5. So as you see, this is my criterion which has been set up in the material card. Okay, and that's all for the material deletion at this moment. And now we're back to the presentation, and Sagar will continue the introduction to the new features.
Okay. Okay. I hope you have a good look at this nonlinear explicit feature. Then we have also the contact thermal resistance, which is has been added for thermal analysis. Let's go to the next slide. So again, this is the gap element, which is a new type of element that has been implemented in Midas NFX. It can work similar to 1D general contact, and again, a few seconds will explain to you how it works.
So let's close this model explicit at this moment, and let's create a model, and let's use the new element type, which is called gap. So basically, gap element can be used to describe contact between two nodes, and that's why sometimes it's called a 1D contact element. But basically, it's a 1D element which connects two nodes, and these nodes must line up. So gap element is normal to contact of the opposite node. This is the basic definition. So at the screen, we see simple plate which has been subjected to the pressure load and which is constrained to the left. Now I'm going to the mesh, and because I want to make a copy of the nodes to create my future gap element. So mesh. Now I'm going to the translate, and I'm checking as my object node, and I'm selecting the nodes from the middle, let's say. So I'm selecting all 3 nodes from the plane. As the direction, I will check the theta direction. Method will be copy, and let's provide the value. This will be minus 1.5 inch, because at the lower corner to the right you see the coordinates, you see the units system which has been currently used, so I'm using the pounds and inches. Okay, so copy. So now I'm clicking on tape, and now I'm going to the create, and from this command we have to click on the other, and from the flyout menu I'm selecting the gap. So this is the main window, main dialog box where you can add your gap elements. And right now, to define this gap property, you have to click on this button, which gives you an access to the gap properties. So in this dialog box, we see several options like initial gap opening, auto gap opening, preload, axial stiffness, transverse stiffness, and some of the friction coefficients. So at this point, I will not tell you everything about all of these options, but I just made some simple examples. So in that case, let's click on this initial gap opening, and I will keep this value 0 because my wish is to, let's say, keep the gap element closed. So this is the one option. You can add some values, and we will make another example in next few minutes. So initial gap opening, let's keep the 0 at this moment. And then basically to add some contact, gap contact element, there is one axial stiffness required. So now I'm specifying the value, so it could be 10,000 pounds per square meter. And let's click on OK. So the property has been defined, and right now I'm choosing the nodes to create the gap element. There is one thing that I supposed to specify. We have to provide the element y-axis orientation. So I'm clicking 1, and my y-axis will be parallel to the x of the global axis. That's all. I'm clicking apply. I'm creating the second gap and the third gap. Okay, so this is the gap element, and right now I'm going to the static heat analysis tab, and let me add the constraints. So I'm selecting the bottom nodes, and I will fix that. Okay, now I'm going to the nonlinear static analysis case, which has been prepared previously. So I'm going to the edit, And from the offsets window, I'm going to activate the gap mesh test. So that I'm adding this element into the current analysis. So it's okay. And let's calculate. So the calculation is done. The model is very simple. And let's display the results. Let me show you the total translation. And let's play the animation. So as you see, okay, so I think it's not displayed well, so I will add the displaying of the mesh edges, and we will increase the deformation scale factor to 5, or maybe more. And right now, let's change the scale factor. So you're supposed to see that this beam plate has been deformed, and this is our edge of the contact. So these gaps are looking like that. So why the element is called the gap? At this moment, my initial gap opening has been set up to 0. So now I'm going back to the model, and from the property, we will change that. So I'm going to the edit, and this time, let's provide the value of, for example, 0.3. So this initial gap opening equals to 0.3 inches at this moment. So let's recalculate the model quickly. So we see even from the graph that something has been changed and in our model. So I'm clicking on the gap. Once again, let's play the animation. So as you see, this is the gap opening, what I told you before, and this is one of the features of this gap element. So, okay. This was example of the gap model, and right now I would like to show you similar model, which will use, let's say, the same gap properties, let's say similar gap properties, but this time the model will, instead of the gap element, will refer the same properties to the rod elements, because we add in this version new feature like constitutive behavior of the rod element, for example. So from this list, you can actually select, for example, tension only, or maybe hook behavior, gap behavior, or maybe nonlinear elastic. This is the new feature for the rod element. And the only difference between the gap elements and gaps from the rods is stiffness. So in the previous example, we have to specify the stiffness manually, what I made. But in this case, this rod element can use the stiffness which comes directly from the cross-section property. So you know already this button. If you click to this on this section, you can choose the section of your rod, for example, and this stiffness, the tensile stiffness, will be calculated. So the gap length in my case is 0.2. I can add this gap as well, and let me display the results for the rod elements with the gap option. This is quite interesting as well. See, it's working very, very similar. Okay, of course, the gap can be used in many situations. One of the, let's say, most popular usage of the gap element is the 2 Hz, let's say, line contact, edge-to-edge contact. And right now I would like to show you some results which refer to the 2D Hertz example. Let me show the model with right view. Oh, excuse me about that. And now I'm displaying the stress, and these gaps elements has been created between these two edges. So now I will back to the model and I will display them for you. So this is the another purpose of usage of the gap element. And if we go once again to the property of the gap, you see that in this case we can use auto gap opening option. So when we click on this option, the initial gap opening will be set to the initial element length. So there is no need to measure the distance between the edges. Auto gap opening. Okay, and that's all at this moment according to the gap elements. Let's go back to the presentation. Okay, so the next improvement refers to the new cable element, and this element is called also as the tension only element, because the tension only, especially in the nonlinear static analysis, can be transmitted via this element. So what we can specify for this type of element is the material. Of course, we have to provide the cross-sectional area, and we have two options which refers to the cable behavior. And right now, at this moment, we have two options, which is called tensile strength, and this is easy to understand because we have to provide the tensile limit with two cable behaviors. One of them is called the perfect plastic, and the second one is irrecoverable failure. So what is the difference? So in some case, when we consider the perfect plastic, in this case, some portion of the internal force will be generated, will be kept even beyond the tensile limit. And the second option refers to the cable, to the situation when the cable will be damaged totally and internal force will be redistributed to the other elements of other cables. And I will show you some examples refers to the, let's say, to the second option, and we will also investigate what is hook length. So let me show you the basic model which refers to the cable. So now I'm going to the property, and I will show you the simple beam. And let's repeat the same command as on the previous exercise. Now I'm going to the translate. I will check the nodes, and I will copy these nodes on the zeta direction with the value of 300 millimeters. Let me click on the preview. Okay, it's fine. So let's click on OK. And at this moment, we're supposed to click on the property. And from the dialog box, I'm choosing the 1D. And from this card, we have an access to the cable property. So in my model, I will create a cable element with.
Welcome to GoToWebinar. Webinars made easy.
I think we have some problem again. So
Is it okay if you sound back? Hello?
okay, it's back. Okay.
Sorry.
Yeah, very sorry about that. Yeah. Okay, so let me start again. So in the dialog box, we have an access to the cable property. So it's obvious that we have to check the material. So the another option is to specify the cross-sectional area. So I'm entering this value. This is equivalent to 5 millimeters of the diameter. And under the cable behavior, we have to check this box. Let's enter the value for the cable element. In this case, it can be like 1,300 megapascals. And let's click on this redistribute internal force, for example. So let me change the name. For example, 5 millimeter diameter cable. And I'm clicking OK. So I just created this property. And from the menu, which is placed here in under element, I am clicking again on this create. And from this tab, I will connect the nodes. So I'm clicking on this node and this node. I'm using the right property, and once again I will change the direction for the cable. I'm clicking OK. B is fine, so let's click on apply. The same for the second cable element, the same for the third one. Okay, so let's click on this button, and at this moment I'm going to constrain the model. So I'm clicking on this load and boundary conditions tab. Let's assign the constraints. So I will use the predefined definition. So I'm selecting the top nodes, and I'm clicking on the fix button. And the second step is to specify the load. And in my example, I will create two load sets. So let's create the first load set, and let's use the force. The force will be applied at the middle node on our beam. So I'm selecting this, and the value will be equal to minus 50,000 Newton on the zeta direction. This is load set number 1, which will be valid for the first subcase. So let's apply, and we will generate exactly the same value for the second load set. But actually, we can use the same load set even for the second subcase. So let me change this little bit to 40,000. Okay, there is no select object, so once again we have to click on the middle node. Okay, we have it, and at this moment I'm clicking on the analysis and results, and I'm going to create analysis case for the nonlinear static. And one more time I will say that cable element is a nonlinear element. That's why we are doing this nonlinear calculation. So let me edit the analysis case. All the meshes has been provided. So right now I'm moving this mesh to the non-active dialog window, let's say. And I'm going to set up the subcases. So I'm clicking the subcase control button. We have to check this geometry nonlinear. As the number of the increments, we can use 50, and we can click on OK. I will create additional subcase, and for the second subcase, we will use this default number of increments, and this checkbox should be also checked. So clicking on that, and on the static load for the second subcase, I'm activating the second load set, and boundary condition will be the same. Okay, so we prepared the nonlinear static analysis, so I'm clicking OK, and let's calculate the model. Okay, let's display the results. So I'm clicking on this multi-step animation, and we will play the animation. Something happened. I think the deformation is so small, and I think it could be better when we will display the output vector for the cable element. So at this moment I'm going to click the insert analysis results, and we will import the cable element forces, for example. So I'm checking the cable force in the axial direction as my result. So I will click on OK. Let's display this output vector. So as you see, now we can investigate the forces on our cable element. So please take a look on the element at the middle. So now our force is increasing, and until the value of 25,000, it should be broken. So I'm showing this situation. So if you go back, the breaking force for this cable element is around 25,500. So according to the increment size, we see this value, which is very close to 25,500 at this moment. So now we see that cable element has been, let's say, broken, and the structure is resisting this force without the middle cable. Okay, so this was the first example with the cable. The second interesting thing refers to the pretension, and at this time I will skip the PPT and we will back to the presentation after this example presentation. So now I'm clicking on the next model, which is exactly the same as previous. And one of the major improvements of new NFX 2014 is the pretension. Pretension, which can be defined in two ways. So first way refers to the pretension as the load, which can be added to current subcase, and the second pretension refers to the initial state of your model. So at this moment, I will use the pretension which refers to the command which is called initial force and stress. So this option allows to provide some initial condition for following element types like rod, cables, bars, solids, and planes as well, and plates as well. So I'm selecting the cable, and let's add the pretension for this middle element. So now I'm providing the value. Value will be equal to 1,500 newtons. And if you want to use other method to assign this pretension, you can select this. You can choose this from the unstrained length and unstraight length ratios. These are additional options which will be helpful to provide the pretension. So at this moment I'm just using the simplest way, let's say. And let's change the name to the load set. Pretension. And let's click on OK. Let me check one thing. Okay. So now I'm going to edit the case which has been prepared previously. And to add this pretension, we are not, let's say, drag and drop this into subcase setting. The thing that you have to do is to click on the subcase control, on the analysis control, and from the initial condition you're supposed to select the right load set. So I'm selecting this pretension load set, and I'm clicking on OK. Okay, and we can calculate the model. Let's display the results. So I'm expecting that the force should act on my beam at the first increment. So to do that, I will insert the cable force result, and I'm clicking on OK. So let's display. So as you see, pretension has been added as the feature which is related to the state of your model. So the value is exactly the same, and of course we can investigate what will happen next with our model. So if we use this slider, you will see that the forces will increase. Okay, another example refers to the hook. And now I will display the model. So we have the same beam, but the only difference is that at this moment this beam has been connected via the cable with this hinge. And let me display the property for the cable. So I'm clicking on the edit, and this time let's check this hook length. What is the hook length? This is option which is related to the distance, and it will be used in the following situation. So if a displacement takes place beyond the hook distance, the element will start to resist of the structure. So let's enter the value. Actually, maybe before we do this, let me display the results for the case when we have no hook option activated. So now I'm clicking on this total translation, and let's see on the model and for its deformation. I will change the scale. So in that case, there is no hook length. So model is responding directly with this cable. Okay? Let's go back to the model and let's add this hook. For example, 2 millimeters. And it can be 2 millimeters, and let's recalculate the model. And now we can observe even from the interactive graph how the response looks like. So we have some proportional region here. And the analysis will take, I think, 10 seconds long, so we can wait. Now we see that the cable broke. It's down. Okay. So let me display the results. So we have the cable with hook. So let's display the results and the animation in that case. And I will use, of course, the real deformation. And we can use the probe for the better view. No. Some displaying problem. Oh, okay. Okay. So it was all, I think, about these cable elements right now. So thank you very much, and now we switch to the presentation.
Okay, thank you very much, Jos. And Jos would like very much to swap the elements. This is why I give you full description. I hope you enjoyed this presentation. So now, so we have this initial force, initial stress. Last feature of this NFX 2014 is a small improvement for CFD, but very important in some specific case. It's called a deflated solver, and it's mainly done to analyze pipe models, because in this case, when the distance between the inlet and the outlet is separated with some large distance, you have some difficulties to calculate. So this deflated solver is actually cutting the pipe into several small sections, and the solver is making the calculation of each of these sections separately and then putting all together. So this is called deflated solver. And this is range under the, you can find this option under the inner iteration stabilized duct flow. Okay, now let's talk about the few options that are coming for the next version of NFX 2014 R2. And we have major improvement for CFD, which will come in the next version. So the first major improvement is called the MRF, multi-referential frame. So this is used to replace the moving mesh for rotating engine. So because right now if you want to simulate that in NFX, you need to use the moving mesh, the CFD contact, the transient flow. So sometimes it's quite complex to simulate. So with this MRF, you can do it without using moving mesh, without using the contacts, and you can simulate steady and transient flow very easily. The second CFD feature which is coming is the fan model. So you'll be able to use a fan model inside the model at the inlet, at the outlet, and to input the fan curve directly into the software. And this third improvement will be the porous media, which is very important if you are modeling a very material with small pores inside. So you will be able to use any kind of porous media in this next version. Of course, it's just a first sight of the new improvement, but there will be more, and we'll talk about that later when we have it. Now let's talk about the next point, which is about the next events that we'll do. So first of all, as usual, you can download for free the 30 days trial of Midas NFX 2014 on Midas NFX website. So you'll be able to use the fully functional version of NFX for 30 days and to try all these new features. Now you have all the technical webinars which are planned, and you can join this session. So we have a second session of this release webinar next Tuesday. If you want to join, you can also join, but it will be almost the same thing. Then we'll have NFX basic training webinar on the 20th of March about the basic training. And the new webinar of the month by Piotr Stepan will be the material nonlinearity modeling in NFX on the 25th of March. So you can register for this webinar on midasNFX.com. You go in the webinar schedule and you'll just register for this webinar. Now you can also find the new NFX industry pages on the website. So if you want to find some specific application and if NFX is fitted for your type of analysis, you can go on the website and search for all the applications we have for our clients. And some of the models like this one, which has been provided by one of the partners, is a staker reclaimer model. You can even download the model from the website, so if you're interested to see how this has been done in NFX and see the results, you can download this model for free by going on the website. And of course, we still have a lot of videos on YouTube, so if you want to understand more about the software, see some video tutorials, or maybe see the previous webinar that we did, you can visit our YouTube channel and look again these videos. Okay, so now it's almost the end. So we'll have a Q&A session. And so you can ask your question in the chat section, and we'll answer right now live about these questions. Okay, we have a few questions. Is it possible to make the screenshot using the hotkey? Yes, you have a possibility in NFX to define some hotkeys for any type of feature, so you can find this screenshot as a hotkey and take the picture, or maybe some part of the model. Okay, we have
actually, next question refers, can we import and export mesh to the other systems? So yes, we can do that. At this moment, we can import and export our models via Nastran format, which is widely used and widely read by other famous pre- and post-processors like Hypermesh, for example, Patram, and FIMAP. So you can use this extension and collaborate with your customers.
okay, I have someone asking on what is the option to have the results during the solution. Yeah, okay, I'll show you that quickly. Actually, when you are doing the calculation, so you see the graph, you can come back to the model and you just right-click on the analysis case, and then you have the option open the result file. So if you click that, you will be able to see, well, not right now, but you will be able to see the result file which has been generated by your model. So you can open it and view the results while the solver is still calculating. Okay, another question, if only the Tesla is available to accelerate the calculation. Well, no, you can use all the graphic cards, but what is required is to have, let's say,
performance.
more than 0.5 teraflops by, yeah, so this is one of the requirements, and then you need also more than 6 giga of RAM integrated on your graphic card. So if you have these two, you can use all the graphic cards as well. But you must be careful because, as I said, some of graphic cards are made for the games, and we cannot tell you that this will be accurate if you're doing to try to do a scientific calculation on it. So you can do more detail about that on. Yeah, okay. I have someone telling me that yes, this is 0.5 teraflop in double precision, not single precision. So this is very important. Double precision. Okay, so this is about the GPU. And something I didn't say, I forgot during the presentation, is that the GPU is available for the multi-frontal solver right now. So not yet for explicit or for CFD. It will be added, but right now we have it for nonlinear dynamic implicit if you want. So it is working for nonlinear dynamic implicit. It's working for nonlinear static. It's working for linear, of course, and other types of analysis. So only explicit and CFD are not available for the GPU at this moment. Okay, do you have more questions? In the cable pretension example, which are the supports of the beam?
The cables to the left and to the right, so only middle, the cable has been subjected to the pretension. So if we back to the model, so I will display that via the cable axial force. Okay, so you see. Yeah, so this cable and this cable supporting the beam. Actually, all of them three of them, but only this one has been subjected to the pretension.
Thank you. Okay, do we have more questions? Okay, so I hope you will join as well the next webinars that we'll do about the basic training and also the nonlinear material, because it will be very interesting. And thank you very much for joining.
Yeah, thank you very much.
Goodbye, and see you next time.